everyone, myself Aarti Kumari. I am from Army Institute of Technology, Pune. So today we are going to demonstrate about our project, which is multilingual multiple choice question generation. So my team members includes Isha Tyagi, Prabal Kumar, and Shivangi Chauhan. So talking about our project, the problem definition of our project is to automate the process of creating objective question assessment using LSTM and transformer models for multiple languages. So these multiple languages includes Hindi, English, French, Korean, and Chinese. So this is the basic flow of our project. Like we have a low level implementation and a high level implementation. So in low level implementation, like we will give the input text, which will be in these 5 languages. And these 5 language will have its own LSTM, these individual LSTM for each languages. And in the high level language model, implements the transformer model for higher level understanding of information and which is common for all the languages. Then we have the distractor, which is used to generate the wrong questions among the MCQs. So this is the basic flow of our project. Now Shivangi will demonstrate further about the demo and the code part.
Coming upon the code part, we have first installed all the needed dependencies. Then we have defined 5 different texts in 5 different languages which we are working upon. Over here, we are training our LSTMs in every language. In this part, we have trained it in Hindi language, and then in French language, and then Korean, Chinese, and English. So over here, as we can see, the accuracy is quite low for every language. The accuracy is hardly had crossed 0.2. So to overcome this problem, we had 2 options, either to use BARD or to use transformers. So in this case, we have used T5 transformers. So this is just training of LSTMs in all languages. Over here, we have consolidated transformer along with the LSTM part. So transformer comes at high level. At the lower level, all LSTMs are trained for all different languages, and over here we are consolidating it with a transformer which is common for all the 5 languages. This code part basically deals with generating of distractors, which we have done using WordNet. So WordNet uses a concept of hypernym and hyponym, so for example, if my correct answer is purple and I want to generate distractors for it, so it will go 1 level up in the WordNet. So WordNet is basically like a thesaurus which has every name along with its class. So for purple, its class would be color. So it will go 1 level up, search for color, and then it will search what all child it has in this particular class. So for colors, it will have red, yellow, green. So then it will suggest these 3 as the distractors. So over here we are generating distractors. So this code part basically deals with generating distractors question answer pair. Then to pair it with a particular UI, because we cannot just hand over this particular code to a user. So to have a particular UI, this would be the UI. User will enter a text over here. So to combine these two, we have used Anvil software. So over here we have called Anvil server, and our Anvil server is up and running. So for this particular test case, I've used a paragraph on Uniform Civil Code. So at first I'll just test. I have this particular paragraph in all 5 different languages. So I'll feed this text and I'll click on generate MCQ. One second. So as you can see, whatever the text which is being fed is there in the back end as well. It takes for about 2 minutes to generate answer, because it takes time, because question and answer pair generation doesn't take that much amount of time, but to generate distractors it needs time, because it has to go through the entire word net and to search for the best distractors it could have. So it would take around 2 minutes. So over here we can see the required MCQ are generated. So it specifies the question, the distractor. So over here if we read, भारत नागरिकों के लिए व्यक्तिगत कानून बनाने के लिए कौन सा नियम लागू होता है, तो it has provided a different distractors, and one of them is the right answer, and then it shows the right answer as well. So at max it can have 6 questions, and depending upon the size of the paragraph, if the paragraph is too short, so it generates question accordingly, but at a max of 6 questions can be generated, and it was quite a good paragraph, so it could form all 6 questions. So now I will change this paragraph in some other language. Let's make it to French. Okay, so these questions are generated for French language. They are the similar questions which got generated for Hindi language as well. Let's change this for Chinese. These are also those 6 questions which were generated for Hindi. Let's just check for Chinese. So for Chinese as well, we have got the questions generated. Now let's check for Korean. So for Korean language as well, we have generated these 6 questions, these similar 6 questions. So lastly we'll check for English language whether all the questions are correct or not. We'll refresh the page. So for English language as well, questions are generated. So we can see these are the same questions which got generated for the other 4 language. So that's how our model works for these particular 5 languages. There are some shortcomings which are yet to be worked upon to generate good quality distractors and to have more accuracy for the particular model. So thank you.